This lesson will review solving linear equations. Let's start with the first example with exercise 1. In order to solve for x, we need to remove any of the constants that are on the same side as the variable. So we will subtract 5 from both sides. That will end up leaving us with 3x is equal to 21. Once we divide both sides by 3 to get x by itself, we will be left with x equals 7. We divide by 3 because the 3 is multiplying by the variable, so we do the opposite operation to get the variable by itself. In the next example, we need to be able to get the variables all on one side. We have an 8x on the left and a 4x on the right, so we're going to subtract the 4x to both sides to keep our x value positive. That's going to leave us with 4x minus 7 equals negative 5. From here, to get the variable by itself, I'm going to add 7 to both sides. So we're going to get 4x equals, and negative 5 plus 7 is going to give us a positive 2. And then we will divide both sides by 4 to get x by itself. This will leave us with 2 over 4, which reduces down to 1/2. In the next example, it's x plus 8 divided by 2. So to get rid of the 2 on the bottom, we need to actually multiply both sides by 2 in order to get this one to work. So when we multiply both sides by 2, we're left with just x plus 8, because the 2 would cancel, equals, and then 2 times negative 6 is going to be negative 12. Subtract 8 on both sides in this problem to get x by itself. And we're actually be left with negative 20. Because remember, a negative 12 minus 8 would end up giving us a negative 20. Finally, with example D, we have to do a little bit more work here. We have to do some distribution before we can actually do this problem outright. So the 6 is going to distribute to both parts here. So we're going to get 6x plus 24. Remember, we were multiplying here. In the next part, make sure you distribute the negative with the 2. So it's minus 2x plus 2 equals 2x plus 20. On the left-hand side, we are going to combine our like terms. 6x minus 2x is 4x. And the 24 plus 2 is going to give me a 26. And that is going to equal 2x plus 20. From here, I want to get the variables on the same side, so I'm going to subtract the 2x from the right side to the left-hand side. So that's going to be 2x plus 26 is equal to 20. Then I will subtract the 26 from the left to the right side, so I'm going to get 2x equals, and it'll come out to negative 6. And then when we divide both sides by 2, we will get an answer of x equals negative 3. In exercise number 2, we're going to justify each of the steps in solving this equation by identifying which property that we are using. So in the first step, you'll notice that 2 times the quantity x plus 7 had changed to 2x plus 14. So the property that we are using in this case is going to be our distributive property. In the next step, you'll notice the 2 of the terms were actually switched. So now we have the 14 and the 4x trading places. When 2 things switch order in an equation, this is going to be the commutative property. Now, let's take a look at what's happening in the next 2 steps here. I'm noticing that there's an x in each of the steps here, the 2x and the 4x, that all of a sudden appears on the outside of a set of parentheses. This is undoing the distributive property, so again, we're going to identify this as distributive. now that we have this distributive taken care of, 2 and 4 are simply added together to make 6x in this step. You'll notice then that 14 is subtracted from both sides in order to get the x value by itself. This is considered to be the additive property of equality. And finally, the last step then is to take this 6 that is in front of the x and divide both sides by 6 to get a final answer of x equals 5. This is considered to be the multiplicative property of equality. Next, we're going to take a look at what happens when equations are known as either identities or inconsistencies. An inconsistent equation is going to be when you get the equation down to two things that are equal, but they're really not. An identity is when you can get two things that are equal, but it actually can't be solved. They would be two equal numbers, like 3 equals 3. Let's take a look at the first example and see what happens here. So to start, we have for two different distribution problems that we need to take care of first. So we're going to leave the 6x alone, but we will need to distribute the negative 2. So this becomes minus 2x minus 8. And on the other side of the equal sign, we will distribute the 3. So this is going to be 3x plus 6. And then the plus x and minus 5 remain on that side. From here, we are going to combine like terms. So 6x minus 2x is going to end up giving me a 4x. So this is 4x minus 8 on the left. And on the right-hand side, we're going to get 3x plus x. So that's 4x. But then the 6 and the minus 5 combine to give me a positive 1. From here, if we were to subtract 4x from both sides, the 4x's would actually completely disappear, leaving me with an equation of negative 8 equals 1. Negative 8 equals 1 is obviously not accurate. It's not equal, so this is what we call an inconsistent equation, because it doesn't actually produce a solution that works. The other type of equations we could have are identities. Identities are true no matter what values you substitute in for the variable. So for example, let's try the example of x equals 3 and x equals 5 in this particular equation here. So we're going to try 5 first. So we're going to substitute 5 into this equation every single time we see the variable of x. So it's 2 times 5 minus 6 plus 5 minus 1 equals 3 times 5 minus 3 plus 2. We're going to clean this up a little bit. So we have 10 minus 6 plus 5 minus 1. 5 minus 3 inside this we know is going to be 2, so 3 times 2 is 6. And then if we clean up both sides, we can add and subtract all the numbers that are on the left-hand side. We end up getting 8, and if we add 6 and 2 together, we also get 8. So we actually have the same number on both sides. That's why this is considered an this is going to be considered an identity, because we should also get something like this once we substitute in the value of 3. So we're going to try this again, except we're going to make this a little bit quicker. If we substitute a 3 in here, it's 2 times 3, so we know it's going to be 6. And again, we're going to be substituting a 3 in for x. On the right-hand side, if we substitute a 3 in, this in here becomes a 0. So 3 times 0 is simply 0, so that means the whole right-hand side will end up equaling 2. So let's find out whether or not this works. 6 minus 6 is 0. 3 minus 1 is 2. 0 plus 2 is 2. So this balances. So no matter which number we use so far, we would see that we actually get the same value. If we actually try to solve this equation like normal, let's see what happens here. So we have some like terms. We can combine the 2x and 1x to get 3x. And I'm going to combine the negative 6 and negative 1 here to get negative 7. On the right-hand side, we're going to distribute the 3, so it becomes 3x minus 9 plus 2, and then if we just combine the last two terms, we see that we get a minus 7. In this case, once you get the same thing on both sides of the equal sign, this is how you can identify that you have an identity for your equation. Exercise 5 wants you to be able to solve these equations and identify whether or not they are identities, so that they match on both sides. If they are inconsistent, where you get two different things on the different sides of the equal sign, or if it's neither and you can actually solve it for a value of x. Try these yourself, so pause the video, and then to check your answers, go ahead and play it and you can see how you did. In problem A, if you were to solve both of these equations, the final answer you would get is actually negative 6 is equal to negative 5, which ends up giving you an inconsistent solution. You can also identify that from the previous step because the variables do have the same coefficients with different numbers that follow them. So you can tell that it's inconsistent before you actually get to the final part. In problem B, make sure that you move the positive 8 first in order to easily solve this particular equation, and then you can multiply both sides by the 2 to eliminate the denominators. If you do it correctly, you should end up getting 4x plus 2 equals 4x plus 2, so this does turn into an identity. In problem C, if you go through this, you can actually solve this for x and get a value of 7. So this one's neither inconsistent or an identity. You can actually get a value. And finally, for the last one, if you're careful with your distributive property and multiplication, you can end up getting an answer of 16x minus 4 equals 16x minus 4, which also gives you an identity for this example as well.